So today we'll look at some further examples of right triangles, using right triangles with trigonometry. So we have an example. An airplane leaves the airport flying at a bearing of north 32 degrees east for 200 miles and lands. How far east of its starting point is the plane? So I've already drawn it out for us here. So we have my plane. Let's say that I have little north, west, east, south here. Well, if I go northeast, this is the degree angle that I should get here. So I want to find out how far east. So this makes my right triangle. So looking at my angle 32, I want to determine using my trig functions sine, cosine, and tangent, where sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Which one should I use? So I have the hypotenuse, because this is right across from the 90-degree angle, and I have the side that's opposite, which is E. So opposite and hypotenuse is sine. So I'm going to use sine for opposite and hypotenuse. So I'm going to plug in what I have. So I have sine of 32 is equal to my opposite, which is E, over my hypotenuse, which is 200. And 200 is for miles. So I'm going to solve for E. I'm going to multiply both sides by 200. I don't have space over here, so it's 200 times, so my 200s will cross out, 200 times sine 32. So E is equal to 200 times sine 32, and I can put that in my calculator, and I know I have to make sure, because I'm dealing with degrees, that my calculator is in degrees. So that gives me 200 sine 32 gives me 105.98. I am going to round to the nearest mile though, so that's going to say 106 miles. Alright, let's go on to the next one. It says a method for surveyors used to determine a small distance d between 2 points P and Q are called the subtents bar method. The subtents bar with length b is centered at Q and situated perpendicular to the line of sight between P and Q. Angle theta is measured, then the distance d can be determined. Find d when theta is 1 degree, 23 minutes, 12 seconds, and b is 2 centimeters. So I've drawn it out for us here, or the images get provided for us here. Looking at this, I have this right triangle here. So if I just take half of this image, this is what I want to use. So everything in reference to here. So I'm looking for this angle, but it's theta divided by 2. And by the way, theta is given to us in minutes, degrees, and seconds. Well, it's 1 degree, 23 minutes, and 12 seconds. So I can't leave it like that. My calculator doesn't do it in minutes and seconds, so I'm going to have to change it to decimal degrees. So that's 1 plus 23 over 60 plus 12 over 3600. And I'm going to just put that in my calculator. And I get 1.3866666. I'm going to stop there, 7 degrees. Alright, so now looking at what I have, again, using our trig functions of SOHCAHTOA, our sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. I'm looking at what I have. I have, compared to this angle here, I have D, which is my adjacent, and I have B over 2, which is my opposite. So that gives me tangent. So let's write it down. We have tangent is equal to, and our tangent of theta over 2 is equal to our opposite, which is B over 2, divided by our adjacent, which is D. Well, I know B is equal to 2. They told us on the previous slide that B is equal to 2 centimeters. So 2 divided by 2 is just 1. So, running out of space. I have tangent of theta divided by 2 is equal to 1, because 2 divided by 2 is 1, over D. I want to solve for D, so I need to cross multiply this. So that's going to be multiply both sides by D and then divide this by tangent. So I'm going to get D is equal to 1 over tangent theta divided by 2. Now if you recall, cotangent is equal to 1 over tangent. So I could, if I wanted to, rewrite this as D is equal to cotangent theta over 2. So let's put that in our calculator. Alright, so here I have it pulled up for us. I'm using my free graphing calculator at desmos.com. As you can see here, desmos.com. And I'm going to use both ways to find my answer, so you can see that both of them work out. So that's 1 divided by tangent of my angle was 1.38667 divided by 2. And that does not look right, so I need to make sure. Sorry, I am not in degrees. So notice this radians is highlighted. I need to change it to degrees. And there, that looks a lot better. So that's letting me know that my distance D is 82.63. Let's do it with cotangent instead, just to see. So I have cotangent of 1 divided, 1.38 divided by 2, and I get the exact same answer because they are equal to each other. So D is equal to 80, and I cannot remember what it was, 82.63, something like that, hopefully. But that's what my D is equal to, and I don't remember, I think it's in centimeters. Yep, it's in centimeters. So D is in centimeters. Part B, it says angle theta usually cannot be measured more accurately than to the nearest 1 second. So how much change would there be in the value of D if it was measured 1 second larger? So here, if I change this to 1 degree, 23 minutes, and 13 seconds, what would the difference be? So again, I would just plug this in at 1 plus 23 over 60 plus 13 over 3600. And I would do everything that I did before. I would plug it right back into the exact same equation, except, let's see what that turns out to be. So that's 1 plus 23 divided by 60 plus 13 divided by 3600. It would be, instead, my degree would be 1.38694 instead. And so this is the number that I would plug into my calculator. So instead, do cotangent of 1.38694 divided by 2 instead. And you can see that the change is 82. Instead of 82.63, it's 82.62, depending on how far you round it to. And so that looks like it's off by a tenth. Excuse me, 100th of a degree. So it'll be off by 100th of a degree. All right. Let's see if we have time for one more. It says Sean wants to know the height of a Ferris wheel. From the given point on the ground, he finds the angle of elevation to the top of the Ferris wheel is 42.3. Then he moves back 75 seats from the second point. The angle of elevation to the top of the Ferris wheel is 25.4. Those degrees are supposed to be there. It says find the height of the Ferris wheel. So if I draw, there's my height of my Ferris wheel. The first one we said is 42.3 degrees. Then he backs up, and this height, pretend like this is a triangle that really works out. So I have 25.4 degrees instead, and this is 75 from this point. But I don't know this point here. So I need to find out my height. So again, using our trig functions, I see that I have angle, I have the adjacent side and the opposite. So that's tangent. So I'll make two different equations. So for the first one, looking at the first triangle here, I would say it is tangent of 42.3 is equal to my opposite, which is my height, over my adjacent, which is x. For the second one, second triangle, I have tangent of 25.4 is equal to my height over x plus 75. So really right now we have a system of equations. We have two unknown variables that we have to solve for, so that's why we have our two equations, and we can actually find it. So I think we should solve both of them for h. If we solve both of them for h, then we can find out what x is. So if I solve both of them for h, excuse me, I'm going to multiply both sides by my denominator. So for this one, I multiply both sides by x, and so h would be equal to x tangent 42.3. And then this one multiplied by the denominator, which is x plus 75, both sides by x plus 75. Sorry. And so that gives me h is equal to x plus 75 times tangent 25.4. So both of them are equal to h, so I can set them equal to each other and solve. Okay, so as I said previously, we have x times tangent of 42.3 is equal to h, and h is also equal to x plus 75 times tangent of 25.4. Well, since these two h's are the same, I can make these two equations the same also. So this is like our system of equations where we would use substitution. And so now I can solve for x because now I only have one variable. So I have x tangent 42.3, and I'm going to bring it down. And I want my x's by themselves. So before I can do that, I need to go ahead and distribute this. So that's going to be x times tangent 25.4 and 75 times tangent 25.4. So I get x